A window, that's the thermal conductivity of glass, right? Measures 2.4 by, this is a big picture window, right? 3.2 millimeters thick. It's a single pane window, right? And we noticed somehow, in 10 minutes, right? 865 kilojoules of heat flow through the window, right? So our Q is equal to 865 times 10 to the third joules, right? Our time is 10 times 60, right, is 600 seconds, right? Our area is going to be 2.4 by 1.8, right? And our thickness here is going to be 3.2 millimeters, right? So times 10 to the minus third meters, okay? So we've got delta Q over delta T is going to be, and that's the delta T, right? 600 seconds, right? Is Ka change the thermal gradient, right? Okay, so whoops, that's changing X. I do it just just there it is. All right, so all right, so now we're all set, right? We want to solve. What are we solving for? The temperature difference. That's not too bad. Okay, so I'm going to go delta Q over delta T. I'm going to multiply by the thickness, right? Divide by K, divide by the area, right? And that should give us the difference in temperature, right? So I'm just putting what these guys in the denominator on this side, right? Put that guy in the numerator. Okay, so our difference in temperature is the heat, 865 E3 over the time, right? So the time is 600 seconds. Right, that's joules. Our thickness is 3.2 millimeters. All right, our K is 0.84. And our area is, we're going to need a little dividing. What is that line called? 2.4 times 1.8. There's a name for that line. I know you know it, but I don't know it. Let's see, 865 times 10 to the third times 3.2 E minus 3 divided by 600 divided by 0.84 divided by the quantity, 2.4 times 1.8. And I get that the difference in temperature from one side to the other is 1.27 degrees Celsius. Okay. Now, just keep in mind, that windows, the air next to a window, a single pane window, is really very cold, right? So if this is the outside and it's winter time, and this is the inside, right? This is maybe we're keeping this at 20 degrees Celsius, right? This might be minus 30 degrees Celsius, right? There's not going to be 50 degrees Celsius difference across this window because the air right next to this is actually going to be sort of rising up, but it's going to be warmer than the air here, right? And the air right next to this will be sort of falling like this, right? Okay, because it's going to be getting cold, right? So the air right next to it on the inside is very, very cold. The air on the outside is very warm compared to the outside air. There might only be a temperature difference of 1.27 degrees. And that's a bunch of heat flowing through that window, right? Okay, so anyway, there you have it.